Hello everyone, my name is Laura and I am the ESR number 3 of the Zephyr project. I am from Colombia and I am doing my PhD at the University of Twente in the Netherlands. I did my bachelor on aeronautical engineering in Medellin, Colombia, my home city, and at the end of my bachelor I moved to Brazil to do my master's at the University of Sao Paulo. During my master's I worked with aeroacoustics, also in aeronautical engineering, and now I am doing my PhD also in aeroacoustics. The noise produced by wind turbines is one of the current main limitations for the further exploitation of wind energy resources. That's why the Zephyr project wants to understand how the environmental condition of complex terrains and urban zones affect the noise produced by wind turbines. And the most important characteristics of these environments is the high turbulence levels. So in my PhD, what I wanted to understand was how the inflow turbulence affects the noise produced by an airfoil. Let's say that an airfoil or a wing is a transversal cut of the wind turbine blade. So I was focused just in a single airfoil or in a single part of the blade. To do so, I conducted experiments in our aeroacoustics wind tunnel, as you can see here. What I did was to place several airfoils, several wing shapes downstream of inflow turbulence. I generate this artificial inflow turbulence using grids and using rods, as you can see installed in the wind tunnel. And then we measure the boundary layer, the wall pressure fluctuations, and the noise produced by the several airfoils. One of the main results of our research of my PhD is that we notice that when we have high free stream turbulence levels, the turbulence inside the boundary layer is amplified and then the trailing edge noise of the airfoil is increased. Also, we demonstrated that the leading edge noise is highly affected by the airfoil geometry. The thick airfoils, that are the ones that we use in wind turbine tips, produce lower leading edge noise compared to a thin airfoil. And then if we understand better these two phenomena, then we can predict better the noise produced by a wind turbine when they have or they are submitted uh, under inflow turbulence condition. Within the Zephyr project, we have several benchmarks, and one of the benchmarks is in an horizontal axis wind turbine. The idea of this benchmark is that we can compare the different methodologies used by the different ESRs to predict the noise or to characterize the wind turbine. Within this benchmark, I have had several collaborations along my PhD. One of the collaborations was with ESR number 8, with whom we compared our methodologies to predict the noise produced by the wind turbine, the entire wind turbine, and we compared the results with real measurements of the wind turbine, and also we predict the leading and trailing edge noise of a single airfoil, and we compared with the wind tunnel test. Furthermore, with ESR number 12, we had a strong collaboration on doing the experiments here at the University of Twente, and also we coupled the prediction methods with shape optimization techniques to try to optimize an airfoil to produce less noise. So I think that one of the main advantage of doing a PhD within an ITN and a Marie Curie project like Zephyr is that we have this strong collaboration between the institutes and the several students. Also, it's important to say that we have received a lot of inputs and feedback from the industry. That is also really important. Well, that's what I wanted to tell you today. I hope you got interested on my PhD and in the Zephyr project. And if you want to discuss a bit more or know a bit more about this topic, feel free to contact us. Goodbye.